Hello and namaste everyone. It's me Sanjeet Thapa Magar. Welcome to my channel Engineering Star. In this video, I will solve the numerical of laterally supported beams that was asked in Provincial University. The first question is was asked in 2019 Provincial University. That is a room of clear dimension 15 meter by 4 meter. This is a room. This is a room of clear dimension, means from inside to inside dimension. That is, this is length is 50 meter and this breadth is 4 meter, is to be covered by 125 meter thick slab. The thickness of RCC slab is 125 millimeter, resting over areas joist. These are the areas joist at an interval 3 meter center to center. Live load on slab is 4 kN per meter square. Design and apply necessary checks. Permissible stress in shear is 100 megapascal and bending is 165 megapascal. So lead joist is resting over 30 centimeter thick wall. The thickness of wall is not given, so we assume it 30 centimeter. Each beam will carry load of 3 meter wide slab. So if this is joist, then this is 3 meter, so this is 3 by 2, that is 1.5 meter, and this is 3 by 2, 1.5 meter. 1.5 plus 1.5 is 3 meter wide slab. Load per meter length of beam. RCC slab is per meter is area times gamma. Area is BD times gamma. B is this 3 meter and gamma is this, no, D is 125 millimeter. So 125 divided by 1000 is 0.125 meter, and unit weight of the slab is 24. So 3 into 0.125 into 24 is 9 kilonewton per meter. So live load is 4 kilonewton per meter square. So for 3 meter it is 4 into 3, that is 12 kilonewton per meter. So it is per unit length, so per meter. Self weight of beam we assume 1 kilonewton per meter. So total load of beam is this 9 plus 12 plus 1, it is 22 kilonewton per meter. Effective span of beam is this is beam, then effective span of beam is this center to center distance is 4 meter, and this half the width of this is 0.3 and half the width of this is 0.3, so it is 4.3 meter. Maximum bending moment is WL square by 8. W is 22 and length is 4.3 square by 8, that is 50.8475 kilonewton meter. So to convert kilonewton into newton, we multiply it by 1000, and similarly meter to millimeter, we again multiply by 1000. So moment is 50.8475 into 10 power 6 newton mm, and Z is m by sigma. From bending equation, m by I is equal to sigma divided by y. So yum divided by sigma is I divided by y. I divided by y is also called z, so z is yum by sigma and Pc is bending compression. So yum is 50.8475 into 10 to the power 6 and sigma Pc is given bending compression that is 165 megapascals. So Z required is 308.167 into 10 power 3 mm cube to convert mm cube into centimeter cube with divided by 1000. So Z required will be 308.167. So in beam we use I section. So whose Z value is greater than this 308. So it have the Z of 392, which is greater than 308. So we choose ISLB 275. ISLB 275. What's Z is 392.4. 392.4, which is greater than this. So area is 42.02. Area is ISLB 275. ISLB 275. Area is 42.04. Depth here is 275. 42.04 centimeter square, and that is 275, that is 27.5 centimeter. TW and TF is 6.4 and 8.8. 6.4 and 8.8, and IOX is 5375.3. 5375.3, and US2 is 25.65. 25.65 millimeter. Check for shear. Maximum shear force is WL by 2. W is 22 and length is 4.3. 22 into 4.3 by 2, that is 47.3 kilonewton. Average shear stress is tau BA, that is B by Yours TW. B is 47.3 into 1000, and yours is 27.5 and TW is 6.4. 6.4, and this is in yours is 275. That is 275 millimeter. So the average shear is 0.4 times this FY 250, which is 100. Average shear stress is given in page number 69. 0.4 FY. 0.4 F5, that is 100. So average shear stress should be less than this 100. So okay. Check for deflection. Maximum deflection is KWL4 upon EIX. W is 22. K for this case is 55384. Length is 4.3 power 4, and this IX is 5375.3 into 10 power minus 7 minus 8. IX is in centimeter 4. 5375.3. E, the value of E is 2 into 10 power 5 megapascal or Newton per mm square. 2 into 10 power 5. To convert Newton into kilometer, we divide by 1000, and mm square is 1 millimeter into 1 millimeter. So to convert meter into millimeter into meter, we divide by 1000 and 1000 here. So 2, this is 5 minus 3 is 2, and 1 2 3 4 5 6. So 10 6 6 plus 2 is 8. So E is 2 into 10 power 4 and 10 power 4, and EX is 5375.3. 5375.3 in centimeter 4. To convert this in millimeter, meter, 5375.3 into in 1 centimeter, there is 1 divided by 100 meter. So power 4. So here also power 4. So it is 5375.3 into 10 power, this minus 2 and 4 is minus 8. So minus 8. So delta will be 9.11 into 10 power minus 3 meter, that is into 1000 gives 9.11 millimeter. So allowable deflection is L by 325. Length is 4.3 and divided by 325, this is 0.0132 into 1000 is 1 2 3 13.2 millimeter. So it is greater than this 9.11. So safe in deflection. Okay. For wave crippling, bearing stress as support is R divided by TW. This is thickness, and length is B plus S2 root 3. So this is force, this is area. So 47.3 is the R, kilonewton to Newton, multiplied by 1000. TW is 6.4 millimeter. 6.4 millimeter. B is width of support 300. Just 2 is 25.65. So it is 21.45 megapascal, so it should be less than 0.75 FI, that is 0.75 FI is 250, that is 187.5. It is less than 187.5 megapascal. So okay, check for wave boggling. Yachts 1 is yachts minus 2 yachts 2. Yours is 275 minus 2, yours 2 is 25.65, yours 1 is 223.7 mm. Slenderness ratio is yours 1 by tw root 3. Yours 1 is 223.7 divided by tw is 6.4 root 3. So slenderness ratio is 60.54. From table 5.1, and for 250 and lambda 60.54, 250 and lambda 60.54, 60.54 is between 60 and 70. For 60 the value is 122, and for 70 112. 122, so by linear interpolation sigma bc is 121.46 megapascal. Load carrying capacity of the wave under concentrated load is sigma bc into area is tw into b. So sigma bc is 121.46, and this is tw is thickness of wave 6.4 and b is 300. This is width of support loss 275. Divided by 2, it is 340 kilonewton, which is greater than 47.3 kilonewton. 47.3 kilonewton. The shear force is only 47.3 kilonewtons, but capacity is 340, so safe. Therefore ISLB 275 is provided. And this question was asked in 2017. All of dimension 20 by 8 meter is to be covered by RCC slab flooring 15 centimeter. To convert 15 centimeter into meter, we divide by 100, so 0.15. Space at an interval of 4 meters center to center, so B is 4. Terrazzo finishing of 2 centimeter. 2 by 100 is 0.02. Terrazzo finishing is provided over our RCC slab. The live load on the slab is 4 kilonewton per meter square, and spacing 4, so 4 into 4 is 16 kilonewton per meter. The joists are resting over 300 centimeter thick walls. Design the floor joist if the permissible stress in bending is 165 and shear is 100 megapascal. The unit weight of RCC and finishing is 24. So this multiplied by this is 14.4 kilonewton per meter, and 4 into 0.02 into 24 is 1.92 kilonewton per meter. So, and assume self weight of beam is 1. So this plus this plus this plus this is 33.32 kilonewton per meter. Support with B is given in equals 300 millimeter. Effective span is this 8 plus 0.3 by 2 plus this is 0.3 meter. 8 plus 0.3 by 2 plus 0.3 by 2 is 8.3 meter. Maximum bending moment. M max is WR square by 8. W is 33.32 into length is 8.3 square divided by 8, that is 286.93 kilonewton. meter, which is 286.93 into 10 to the power 6 Newton millimeter. Sigma BC is given in question 165. Permissible bending stress in bending 165. Z is m by sigma 186.93 into 10 power 6 divided by sigma 185, that is 1738969.7 mm is cube. To convert mm cube to centimeter cube, we divided by 1000, so it is 1738.97 centimeter cube. So we should choose Z greater than this 1738. Z greater than 1738. We can choose this ISLB 550. I have chosen ISSB 450. For ISSB 450 at 87.2 kg per meter, all the values are taken from steel table. This ISSB 450 at the rate 87.2. The first second last Z is 1742.7. 1742.7. This approximates 1740. Area is 111. Area is I have chosen this second last, so area is 111 point something centimeter square. Yours is 450, and this B is 250. T of and TW are 13.7 and 9.8. 13.7 and 9.8. Yours is 450. B is 250. B is 250. Yours 2 is 31.9. 31.9, and yours 1 is 386.2. 386.2. Yours 1 can also be calculated as yours minus 2 yours 2. Yours is 450 minus 2 into yours 2 is 31.9, so 386.2. Check for shear. Maximum shear force R is WL by 2. W is 33.32 and L is 8.3 divided by 2. This is 138.278 kilonewton. Average shear stress is R by yacht into TW. So R is 138.278 in Newton. It multiplied by 1000. Yacht is 450 and TW is 9.8. So tau BA is 31.36 megapascal. So it is less than 100. The maximum permissible is 0.4 times 250 is 100. So it is less than 100. So safe and shear. Check in deflection. Del is K into WL cube by EIX. For beam supported at both ends with UDL, K is 5 by 3, 84. So A is in kilonewton per centimeter square. It is 2 into 10 to the power 4 kilonewton per centimeter square. In megapascal or newton per mm square, it is 2 into 10 to the power 5 newton per mm square. W is 33.32 into this 33.32 into length is 8.3. So W is 276.556 kilonewton. Del max is this into 8.3. It's in meter. To convert it in centimeter, we multiply by 100. This is in also centimeter. This is also in centimeter, and this is in kilonewton, and this is E is kilonewton per centimeter square, and this is I think in centimeter. IX is 39200 centimeters, so this value must become in centimeter, which is 2.626 centimeter. Allowable deflection is given in clause 3.13.1.2. 3.13.12 in limiting deflection. In limiting vertical deflection, the deflection of member shall not be such that as to impair the strength or efficiency of structure and lead to damage to finishing. Generally, the maximum deflection should not exceed 1 by 325 of the span. 1 divided by 325 of span. One by 325 of span is 8.3 in meter. In centimeter, it is 8.3 into 100, that is 2.554 centimeter. So it should be greater than this, but it is less than this. So this section is slightly inadequate in deflection, so we can choose another with slight higher section. In exam, if you have time, then you can choose the section with slightly higher Z section, but I have taken this. Check for web crippling. Bearing stress at support is R divided by TW, B plus just 2 root 3. R is 138.278. 138.278 into 1000 divided by TW is 9.8. B is 300. Just 2 is 31.9 and root 3. So it is 39.718. So bearing stress is given in clause 6.3. Clause 6.3. Bearing stress is the bearing stress in any part of a beam when calculated on the net area of the contact shall not exceed the value of sigma p, which is 0.75. Maximum bearing stress is 0.75 Fy. 0.75 Fy, that is 0.75 into 250 is 187.5 megapascal, and it is less than 187.5. so safe in web crippling. So in boggling, cylinder rest ratio is just 1 divided by TW into root 3. So cylinder rest ratio is 68.257, which lies between 60 and 70. It is in table 5.1. 68.257. $68.257. It lies in between 60 and 70. For 250, in 60 it is 122, and in 70 it is 112, 122 and 112, 122 and 112. By interpolation, sigma AC is 113.743 megapascal. Load carrying capacity is sigma AC times TW into B. 113.743 into TW is 9.9 and B is the bearing width is 300 plus support width is 300 and section is 450. So 300 plus 450 divided by 2. 300 plus 450 divided by 2 is 525. So it is 585.208 kilonewton, which is greater than R. So okay, this is the figure. This question was asked in 2017. A beam of 6 meter effective span. 6 meter. And this is, if clear span, then this is from inner to inner, but this is effective span. So we can draw from center. Concentrated load of 50 kilonewton at mid span. Concentrated load of 50 kilonewton at mid span, excluding its self weight. Design the beam assuming allowable stress and deflection according to IS 800. So according to IS 800, sigma bending is sigma bending is sigma bending is 0.6605. 0.66 into 250 is 165. Sigma bending compression and bending tension is 0.6605, that is 0.66 into 250, that is 165 Newton per mm square. Concentrated load is 50 kilonewton. Self weight we assume 1 kilonewton per meter. Support width is the compressive flange is held against lateral displacement. This is the I section. So it is held against this lateral direction, in this lateral direction. So held against lateral displacement, so it is laterally supported beam. If support thickness is 250, check the design for shear, deflection, bearing, web crippling and web buckling. Effective span is 6 meter. Bending, maximum bending moment is this. WL square by 8 due to self weight and PL by 4 due to this 50 kilonewton. This is 50 or P. So this lies in center, so here it is P divided by 2 and here it is P divided by 2 and this is L divided by 2 and L divided by 2. We need to find bending moment at center, so it is P by 2 into L by 2. P by 2 into L divided by 2 is equal to P L divided by 2 to the 4, PL by 4. And WL square by 8 due to UDL. So here is 6, here is 6, P is 50, W is 1, so 79.5 kilonewton meter, which is 79.5 into 10 power 6 Newton mm. Z required is m by sigma BC, 79.5 into 10 power 6 by 165, so it is 481.82 centimeter cube. We need to choose Z slightly greater than this 481. Z 481 means this is slightly greater than 481, so it is ISCLB 300. ISCLB 300 at the rate 37.7. ISCLB 300 is 37.7 kg per meter. Kg per meter. So area, what is this 300? Area is 48.1. 48.01, this is 48.1. B is 150. B is 150. TW and TF are 6.7 and 9.4. 6.7 and 9.4, both in mm. IOX is 7330 centimeter cube. That is nearly equal to 7330. ZOX is 489. .9, that is 489. YOX1 and YOX2 are 245.1 and 27.45. 27.45, YOX1 is 245.1. 245.1. YOX1 can also be calculated as YOX minus 2 YOX2. YOX is 300 minus 2 into YOX2 is 27.45, that is 245.1. Check for shear. Maximum shear force is WL by 2 and P by 2. Is L W and this is L. So WL will be total vertical load and this will bear WL divided by 2 and this will bear WL divided by 2. So shear force is WL by 2 from UDL, WL by 2, and this is P in center, so this is P by 2 in upward direction and P by 2 in upward direction. So shear force is this WL by 2 plus P by 2. WL by 2 plus P by 2. So we get 28 kilonewton. Average shear force is R by S TW. which is 13.93, less than sigma permissible. For sigma permissible average shear stress is, this is the maximum shear stress, but average shear stress is 0.4 times Fi 250, that is 0.4 into 250 is 100. This be 100. So 13 is less than 100, so safe in shear. In deflection, del is k into W into L cube by E Ix. K is 5 by 384 in this case, and E is 2 into 10 power 4 kilonewton per centimeter square. Ix is 7330 centimeter 4. So W is total load WL plus P, 356 kilonewton. So deflection del is this 1.073, and allowable deflection is 1 by 325 into 600, that is 1.846, which is greater than this del 1.074, so safe in deflection. Then check for equivalent. Bearing stress as support is R divided by TW B plus S to root 3, which is 14, which is less than R. No, which is less than this. Which is less than 0.75 into 250, 0.75 Fi, that is around 185. So safe. Check for wave buckling. Slenderness ratio is S1 by root 3 TW. S1 is 245.1, root 3 divided by 6.7 is TW. So lambda is 63.36, which lies between 60 and 70. Front table 5.1. For 60 it is 122, and for 70 it is 112. For 250, 122 and 112. 122 and 112 by interpolation. Sigma AC is 118.64 megapascal. Load carrying capacity is sigma AC into TW into B. So B is this bearing width plus this section divided by 2, that is 350 plus 150, 400. So load capacity is 370.96, which is greater than 20th, so safe. This question was asked in TU 2065 in and in Purvanchal University 2016, and this is like 2013 chance. A hall of clear dimension 15 by 6.5 meter. 15 by 6.5 meter is provided with 12 centimeter thick stone slab rolled over a rolled steel beams 3 meter center to center, 3 meter center to center. A wearing coat of 2 cm thick cement concrete is placed over 10 cm thick lime concrete. The compression fans would be supported throughout its length by providing grooves in slab. That means this is the case of laterally supported beam design and intermediate. This is intermediate beam with the following data. Live load, unit weight. Live load is 4 kN per meter square. Unit weight of stone is 24 kN per meter cube. Unit weight of concrete is 24 kN per meter cube. Unit weight of limestone is 18 kN per meter cube. This is the 6.5 clear. distance, and the bearing width is 300 and 300. So effective length is clear length plus width divided by 2 plus width divided by 2. Clear length is 6.5 meter and width is 300 millimeter, that is 0.3 meters. So 0.3 divided by 2 and 0.3 divided by 2 is 6.5 plus 0.3, that is 6.5 plus 0.3, that is 6.8. The bearing width is assumed to be 30 cm or 300 mm. It can be denoted by A or B. Now load calculation for stone is 12 cm thick. 12 cm to convert in with meter, it is 0.12, and 3 meter is center to center distance, and 24 is for stone, it is 24 km per meter cube. So this is 8.64 km per meter. For cement concrete, it is same 3 and gamma is 24, but 2 cm thick concrete, 2 divided by 100 is 0.02, so it is 1.44 kN per meter. And lime concrete is, for lime concrete, this is 10 centimeter, that is 0.10 divided by 100 is 0.1, and unit weight is 18. 0.1 18, this is center to center, so 5.4 kN per meter. Assume self weight to be 1 kN per meter, so total load is this plus this plus this plus this, it is 16.48 kN per meter. To convert kN in Newton, we multiply by 1000, and to convert this meter into mm, we multiply by 1000. This 1000 cancels, so 6.48 Newton per millimeter. Maximum bending moment is WL square by 8. W is 16.48, L is 6.8 square by 8, it is 95.254 into 10 power 6 Newton mm. Permissible stress in bending is 165 and shear is 100. We assume Z is m by sigma b. M is 95.254 into 10 power 6 and sigma b is 165, so Z is 577.299 centimeter cube. From we choose the value of Z higher than 577, so 965 we choose. For ZX 965.3, the section is ISLV 400. ISLV 400. For this, area is 72.43, H is 400, the other depth is 400, and TW is 8, TW is 8, IX is 19306, 19306.3 centimeter 4. Yours 2 is 31.90. Yours 2 is 31.90. Yours 1 is 336.2. 336.2. Yours 1 can also be calculated as d minus 2 yards. D is 400 minus 2 into yours 2 is 31.90, that is 336.2. Shear force is WL divided by 2, 16.48 into 6.8 divided by 2, which is 56.032 kilonewton. Shear stress is R by D TW. For I section, shear force is resisted by this area. So the depth is D, 400, and TW, this is a TW 8, and R is, this is the area which radius shear force, and R is 56.032 into 1000. So shear force is 17, which is less than 100, so safe. This is 0.4 into Fy is 250. 0.4 into 250 is 100. This 100. Now check for deflection. Del permissible is L by 325. L is 6.8 to convert in meter, multiplied by 1000. So it is 20.90 millimeter. Del calculated is 5 by 384 into WL cubed by EI. So E is 2 into 10 power 5 Newton per mm square, and I is Ix is 19306.3 centimeter 4. 19303. To convert centimeter power 4 in millimeter power 4, we multiply by 10 power 4, and length is 6.8 in meter, so in millimeter it is 6.8 into 1000, and this 3 will be as it is. And W is this UDL into length is 6.8 meter, in millimeter it is 6.8 into 1000, and this W is UDL is 16.48. 16.48 kilonewton per meter. .48 kilo Newton per meter, that is 16.48 in Newton, it is 1000, and divided by 1 meter. 1 meter is 1000 millimeter, so it is 16.48 Newton per millimeter. So 16.48 This is also in Newton, and this is also in Newton, and all the other values are in millimeter, so this must come in millimeter. So this is less than this, so safe. Check for whip crippling. Bearing stress has supports is R by TW plus S2 to 3. By putting the values, it is 19.716, which is less than 187.5 or 0.75 0.75 into 250. So this is less than this, so okay. Check for web buckling. Slenderness ratio is S1 by TW 3. By putting this value, slenderness ratio is 72.785, which lies between 70 and 80. Table 5.1, 70 and 80. And 80, and for 250, for 70, sigma AC is 112 and 101. 112 and 101. So by interpolation, sigma AC is 108.932 megapascal. Load carrying capacity of wave on the concentrated load is sigma AC into TW into B. Sigma AC is 108.932 into TW is 8. And this B is the A or B value. This is bearing width is 300 plus the section depth is 400, so 400 divided by 2, 300 plus 200, it is 500 into 8 into 108.932, that is 435.728 Newton, that is 435.728 Newton, which is greater than this 56 56.032. So safe. This question is similar to 2016 question. A hall of clay dimension 15 meter by 6.5 meter is provided with 13 centimeter thick stone slabs over a rolled steel beams 3 meter center to center. A wearing coat of 2 centimeter thick cement concrete is provided over 10 centimeter thick lime concrete. The compression flange is provided throughout its length by providing grooves in slab design and intermediate beam with following data. Live load is 4 kN per meter square. Unit weight of stone is 24 kN per meter cube. Unit weight of concrete is 24 kN per meter square. Unit weight of lime concrete is 18 kN per meter cube. Since the compression flange, this is I section, and this is tension flange, compression flange, and this is tension flange. If load is from upward, then compression flange, this is provided throughout its length by providing grooves in slab. So this is the case of laterally supported beam. So step 1 is selection of truss section from bending criteria. For stone slab, it is 13 centimeter, that is 0.13, and center to center distance is 3, and gamma for stone is 24, so it will be 9.36 kN per meter. For lime concrete, it is 10 centimeter, so 10 centimeter is 0.1, center to center is 3, and unit weight is 18, so it is 5.4 kN per meter. Cement concrete, 2 centimeter thick, 2 centimeter is 0.02, and this is center to center distance, and 24. For cement concrete it is 24, so it is 1.44. Live load is 4 kN per meter square, that is 4 into, this is center to center distance, so 4 into 3, 12 kN per meter. Self weight we assume 1 kN per meter, so the 9.36 plus 5.4 plus 1.44 plus 12 plus 1 is 29.2 kN per meter. Suppose width is not given, so we assume 300 millimeter or 30 centimeter. Effective span is 6.5. Plus this is 0.3 meters, so 6.5 plus 0.3 by 2 plus 0.3 by 2, it is 6.8 meter. Maximum bending moment is WR square by 8, so it is 168.776 into 10 power 6 Newton mm. Sigma BC is 0.66 Fy, 0.66 into 250 is 165. Z required is m by sigma BC, that is 168.776 into 10 power 6 by 165, it is 1022.885 centimeter cube. So we should choose the section with Z greater than this Z required greater than 1022, so which is 1170 with ISWB 400. ISWB 400. ISWB 400. ISWB 400. So Z is 1171.3. 1170 around, and yours is 400. Area and B is 85 and 200. 85 and 200. IOX is 23400. Around 23400. TW and T of is 8.6 and 13. 8.6 and 13. Yours 2 is 29.75. 29.75. Yours 1 is 340.5. 340.5. Yours 1 can also be calculated as this 400 minus 2 into yours 2, 29.75, that is 340.5. IOX is 23400. 23400 around. Now check for shear. R is WL by 2. W is 29.2, L is 6.8, and 2 is 99.28 kN. Average shear stress is R divided by S into TW. It is 28, which is less than 11.112.5. So safe. Check for deflection. Del is K WLQ by EIX. K is this, and E is 2 into 10 power 4 kilonewton per centimeter square. W is 29.2. 29.2 into 6.8. It is 198.56 kilonewton. So there will be 1.737 centimeter. Allowable deflection is 1 by 325 of 680. 6.8 is 680 centimeter. So it is 2.092 centimeter, which is greater than 1.737, so safe in deflection. Now check for wave crippling. Bearing stress as suppose is R by TW, B plus S2 root 3. So it is 32.84, which is less than 0.75 Fy, that is 187.5. So safe in wave crippling. Check for wave buckling. Slenderness ratio is just 1 by TW into root 3, which is 68.58, lies between 60 and 70. From table 5.1. For 250 and for 60 it is 122 and 112 for 70, 122 and 112, 122 and 112. So by interpolation, sigma AC is on the 13.42 megapascal. Load carrying capacity is this multiplied by TW into B. TW is 8.7, B is B plus Z by 2. This is bearing width, and this yards is, in our section, yards is 400 divided by 2. The 300 plus 200 is 500. So it is 487.71, which is greater than R, that is 99.28 kilonewtons. So okay, so this is the figure, and this is the last question from this chapter, design of beam. The question is, a hall of dimension 15 meter by 6 meter, 15 meter by 6 meter is to be covered by RCC slab flooring 12 centimeter. 12 centimeter is 0.12. Resting over RS joist space at 3 meter center to center, and terrazzo finishing 2 centimeter thick. 2 centimeter is 0.02. Over the RCC slab, the live load is 4 kilonewton per meter square. This 4. And The joists are resting over 30 cm thick wall. B is 30 cm, that is 300 mm. Design the floor joist. These are the floor joist. Joist is small beam. If the permissible stresses in bending and shear is 165 and 100 respectively, the unit weight of RCC and finishing is 24. RCC and finishing is 24. So self weld we assume to be 1 kN per meter. So 8.64 plus 1.44 plus 12 plus 1 is 23.08 kN per meter. Effective span of beam is 6 plus this 0.3 by 2 plus 0.3 by 2. 30 centimeter is 0.3 meter and this is 6 meter. So it is 6.3 meter. Maximum bending moment is WL square by 8. So it is 11,114.5 into 10 power 6 Newton mm. Z required is m by sigma BC or sigma BT. Sigma BC is 165. So 114.5 into 10 power 6 over 165 is 693.5 centimeter cube. We have to choose the value of Z greater than this. The value of Z greater than 693.9, that is greater than 694. I have chosen Z at 751, which is greater than 693. So ISLB 350. ISLB 350. Z is 751. 751.9. 751.9 is greater than this. So yours is 350. Area is area is 63.01. 63.01. The unit weight is 49.5. 49.5 kg per meter, and TF and TW are 11.4 and 7.4. This is 7.4. IX is 13158. 13158.3. Yours 2 is 30.85. Yours 1 is 288.3. 30.85, 288.3. Check for shear. Maximum shear is WL divided by 2. If this is beam, then this is W and this is length. So W into length is load, and here will be WL divided by 2, and here will also WL divided by 2. So shear force will be WL divided by 2, that is 72.7 kN. Average shear stress is force divided by area. For I section, area shear stress is resisted by this area, that is depth into thickness of web. 350 into 7.4, it is 28.06 megapascal, which is less than 0.4 into 250, that is 100. So Okay, now check for deflection. Maximum deflection tail is K into WLQ by EIX from clause 7.5.9.2 of IS 883 1994. The K value and del value is given in this code. So maximum deflection is 1.8 centimeter and allowable deflection is 630 divided by 325, that is 1.938 centimeter, which is greater than this 1.8. So save and check for wave crumbling. Bearing stress as support is R divided by TW B plus S2 root 3. It is 27.8, which is less than 0.75 into Fi, that is 250. So it is 187.5. So okay, this is given in clause 6.3. Bearing stress 0.75 Fy. 0.75 Fy. Now check for wave buckling. For wave buckling, slenderness ratio is S1 root 3 upon TW, that is 288.3 divided by TW is 7.4 root 3, which is 67.48, which lies between 60 and 70. From table 5.1, for 250, for 60 it is 122, for 70 it is 112. 122, 112. Sigma AC is from interpolation 114.52 megapascal. Load carrying capacity is this. Load carrying capacity of a wave under concentrated load is this 114.52 into TW is 7.4 and B is center to center distance is 300 plus this yards is 350. 350 divided by 2, it is 402.5 kilonewton, which is greater than 72.7 kilonewton. 72.7 kilonewton. So safe. So ISCLB 350 at the rate 49.5 kg. 350 ISCLB 350 49.5. 350 at the rate 49.5 kg per meter may be provided at 3 meters center to center. So thanks for watching. Like, share and subscribe the channel.